What's up guys, this is Andy. I'm going to show you how I created this 3D printed phone holder using Rhino and Grasshopper. Okay, so I started with a couple curves. I brought these into Grasshopper. I'm basically dividing the curve here just to understand what the loft is going to look like. I was having a lot of issues lofting these two shapes together, these two curves together before. There was a big effort to get the exact amount of control points on each curve for them to loft in the way that I wanted to. So that's what I was doing here. Those go down into these move commands where I'm just basically taking them and moving and copying them up into the shape that I want them to loft into. That gets lofted into the phone holder, and then this is the move distance that I use. This is all in millimeters because the 3D printer reads millimeters. After that, I box it to make it a solid object, and I'm just taking, instead of doing a contour, I was having issues with just running a straight contour command on this object because the loft was just like giving me troubles. Instead, what I did was I just created this circle surface and then moved it up a bunch of times, essentially mimicking what a contour tool does. I'm moving it up 0.5 millimeters each step, which is what I need for my printer because I have a 1 millimeter nozzle head. The good rule of thumb is that you want to do half the distance in the Z direction between your layers. That's typically the sweet spot, half the distance of your total nozzle diameter. So I took those and then I did this intersection command to get basically like the curves that I need. So this is essentially what I'm doing is finding the tool path for the printer to use. So this would essentially be one lap around with the printer. It would just follow these curves. And then move up to the next one. So take the curves. I really want to have 2 laps because as I was testing this, 1 lap just wasn't good enough. 1 layer, so the wall thickness was only like 1 millimeter and it was just too flimsy. So what I did was I've offset this inward and then basically woven those two together. So it's taking 2 passes for each layer. So it's a double wall thickness, which ends up being much more rigid of a print. And then this final command, I'm just like exploding it into the different points and lines. You see like each one of these points is what the printer is going to read. It's going to go from point to point. Where I need more detail is where I needed more points. So like around these like little curves, I needed more points there for it to get the detail. When it's on a straight line, it doesn't need as much detail. And this is a final curve. So this is one continuous polyline curve, and I'm trying to find the seam point right now. I think it's somewhere in a corner. The seam point is basically, oh, here it is, where the printer head travels up. So it's basically going to start and end here on the print. So it'll come around, it'll move to the next line, it'll do that line, it'll come around and then move up and then continue that way, the full thing. So the seam is actually inside of the print, so you don't really see that on the finished print. And then the last step for me here was to use this component that I got from a book. It's called Advanced 3D Printing. I could look it up here. Advanced 3D Printing with Grasshopper. Yep, this is it. So this book basically gave me that command in yellow that I use. This basically just like creates your G-code for you from your points. So you plug all the points in here, and then there's a series of steps that you have to do. This again is tailored to my specific printer and nozzle. But what it does is it creates the G-code here that the printer reads. Once I have this, I copy all of this data, I put it into a panel, and I'll save that, and then there's a different software I need to open. It's called Repetier Host, which is a great software that you can do custom G-code on. And then I'll basically load my G-code files, and I went through 5 versions of this print to get it how I liked it. So this basically converts that text into a G-code file that your computer can read, or the 3D printer could read, and you saved a file onto your SD card, and then you're printing. So there you have it. Okay, this is the warehouse, aka my shed, where I have the 3D printer set up. This is what prints it. Goes on this bed. It takes about 2.5 hours. This is what the print looks like when it starts. Here's it midway through the print.